So, hello everybody. My pleasure to introduce my colleague, friend, and co-conspirator in trying to set right U.S. flood management policy, Guy Nordenson, who is our speaker today. He is a professor of structural engineering and architecture here in the architecture school. He has degrees from MIT and Berkeley and was a Loeb Fellow at Harvard. He's also the principal at Guy Nordenson and Associates in a design, design, engineering, architecture, has all of that in New York City. Most interesting, if you read his resume, is that he worked briefly for our Buckminster Fuller and Isamu Noguchi, which must have been a fascinating experience. Guy is civic-minded, and his high degree of involvement in policy-related activities is reflected in his membership on the New York panel on climate change. There are a couple of other Princeton faculty are involved. That's the group that provides technical advice to the city in trying to, in its attempts to develop proactive adaptation policies for dealing with climate change, and with its importance was increased in the wake of the pain that Hurricane Sandy wreaked upon the city. He was also commissioner and secretary of the New York City Public Design Commission for 10 years, which is also, like the New York panel, a mayoral appointment. And he also served on a state panel on the post-Sandy cleanup questions. Most important, in my view, is Guy was a driving force behind the development of New York City's seismic code for making buildings earthquake-proof. And I don't think we've had a test of that in the meantime, but one of these days we'll see. And that was before he got involved in the flood issue. His research at that time focused on earthquake engineering and code development, but more recently, he has become a national leader in unifying design, engineering, climate adaptation, and flood hazard mitigation research. And he's part of a thriving group we have here at Princeton, which covers all the bases on that set of issues. Most importantly, he tries to find ways to propagate this unification through not only his interaction with government, but through the next generation of students who we hope will take up the cause, including ARC 519 course here, climate change adaptation and urban design. Today, Guy is going to speak on climate adaptation by design, and let me welcome Guy.
Thank you very much. Thank you, Michael. The reason I'm here, the reason that I've been doing this now for almost 10 years. Can you hear me okay? No. That's because I don't have this in front of me. How's that? Better? Okay. Thank you, Michael. One of the reasons that I'm here and that I have been working in this area is because of Michael, who encouraged me a little over a decade ago to get involved in this area, and we have collaborated ever since, so it's a real pleasure to be introduced by Michael. Today I want to go through a range of projects that have been done over the last 10 years, all which took place here at Princeton through this group that Michael alluded to, that includes Michael, Ning Lin in the School of Engineering, and Paul Lewis here in the School of Architecture. What I want to try to explain through these examples, and then a little bit afterwards through some discussion about a proposed approach to coastal flood hazard mapping, is the way in which design can help to frame the questions that are by necessity to be explored through science and policy. And I hope that I'll be able to make that clear to you today. All these projects that I will show you today, and there's 7 of them ranging over the last 10 years, have all been an effort to present an approach to coastal resilience and climate adaptation that is driven by certain basic design considerations and ideas. So, for example, the use of natural infrastructure or nature-based features or wetlands or islands to help mitigate the effect of storm surge is an important idea that has emerged more or less since the Hurricane Katrina in New Orleans, and which we tried to advance through the projects that we've been developing. As some of you in the room have learned, working on this problem, it's an extremely difficult problem, how to account for the energy dissipation that is contributed by wetlands and islands and other features, coral reefs, oyster reefs, etc. How those contribute to the resilience of a coastline, to the performance of engineered structures, is a difficult problem of analysis and science, and one that I think so far has been driven in part by the idea itself as advanced through these different projects. I'll go through other examples of this kind of process with these projects. So going back now a number of years, this is a project called On the Water Palisade Bay, which we initiated here at Princeton in the School of Architecture, which was my first opportunity to work with Michael. Michael wrote the introduction to this book. We published the book at the conclusion of that research project. And Ning Lin, who was then a graduate student in the School of Engineering, also contributed to the work that we did here. This is an image that we produced in the book, which helped a lot over the years to clarify the notion of using structures in the water. At the time, this was somewhat taboo, the idea of building in the water in the wake of Westway and other projects that had been stopped in New York by environmentalists. The idea of building in the water was not something that first came to mind. And one of the things that we did with this project was change that perception and change that idea for the city. And some of that was driven by these images, as you will see. Here the idea was building islands offshore that would help to dissipate the wave energy as it approached lower Manhattan, but also soften the edge and then build up some actual physical protection in levees and other means on the edge. Basically, this idea has been reconceived a number of times, and in fact now is behind a project that is underway post-Sandy and lower Manhattan. One of the things that we did with this project was conceptualize the upper bay of New York as a public space. I'll come back to that in a second, but think of this place as not just a problem, but an opportunity with which we could transform the perception of this location for the region. If you look at the maps on the subway, you'll notice in New York, you'll notice that New Jersey doesn't exist. So the actual shape of this bay doesn't really come to mind to most New Yorkers. And so one of the first steps that we did was identify this figure as a place and as an opportunity for study and investigation. And we had a lot of whimsical ideas of ways in which we could contribute to the coastal resilience within the Upper Harbor. We talked about the way in which it resembled the notion of Central Park that emerged in the early 19th century as a matter of public policy, driven not just by Olmsted, but Horace Greeley and many others who felt that Central Park, a public space in the city, was an important way to gather all the various constituents in the city, creating a kind of incubate, not incubator, I don't have the right word, but a place where everyone could interact and get a larger sense of the city. And we felt that that would also be a contribution of this Palisade Bay that we identified in the Upper Harbor. This, on the heels of 9/11, was a notion of also gathering together the communities on both sides of the New York-New Jersey border. Another idea that we started with this project and has continued throughout all the projects is the notion of the continuity of the bathymetry, the underwater landscape, and the topography. That there is no such thing as a distinct water's edge, but that there is a dynamic interface between water and land, and that we need to conceive of that continuity both in the way we think about it, but also in the way we analyze the problem. And in fact, this work, Jim Smith was involved in this, and Ning Lin here at Princeton, was the very early start of doing studies using these models to investigate the contribution of islands that we were proposing in the harbor to the improvement of the coastal resilience, the dissipation of wave energies, and so on. So trying to bring together hurricane science, storm surge analysis, and design as an interactive process to develop and advance these ideas. We also used this as an analysis opportunity to look exactly at all the different conditions around the coastline. Believe it or not, there is no synthetic coastal map produced by anyone, not including the Port Authority of New York, that identifies what is the continuity of protection that exists around this edge, or what is the continuity of ecologies and industrial uses and so on. So we used this opportunity to start that process and develop an atlas, as we called it, of those edges as a way, again, to conceptualize the whole, breaking it down in these different units, analyzing, in this case, using Google Map and Bing to look out at a diagonal at these different sites and try to map as best we could these edge conditions, which had not been mapped and since have really not been mapped in great detail. Another design tool were actual experimental efforts to look at ways in which fluid dynamic flows, sediment deposition, and so on could start to inform the shapes that we were proposing for these interventions. So a lot of this was not necessarily purely scientific based, but is a way of hands-on analysis and design to try to begin the process of proposing a geometry and then developing that geometry through further study. This had quite a lot of influence to start with through an exhibition that we helped organize at the Museum of Modern Art called Rising Currents, which was around the same time in 2010 and was based on the research that we had done in the book that we had published, and disseminated these ideas broadly through the city and the state. It was, putting it in the Museum of Modern Art was important. It took me about a year to convince them. And the reason I thought it was important was it was so out of sync, really, with what the museum is expected to do. And I think that helped draw attention to the question. It began a whole series of social interventionist projects that emerged at MoMA ever since. So there have been a number of other initiatives modeled after this particular exhibit that have continued both at MoMA and elsewhere in the United States. The basic idea in this case was to look at this same place that we had studied, divide it up into 5 different sub-regions, and then assign those through a competition to a number of design teams that included architects, landscape architects, and scientists, and then they produced these ideas and images that were displayed at MoMA on how these 5 different areas could be made more resilient through the intervention both of natural-based features and other coastal adaptation. It educated a whole new group of architects into this field, some of whom, Kate Orr, for example, have gone on to make a career out of this. Kate did not do this before this exhibition. She is now running a center at Columbia, a MacArthur Fellow, and has become quite an authority in this field, triggered by this exhibition itself. And many others. Paul Lewis was also part of the exhibition, has continued to work in this area. Paul teaches here in the School of Architecture. The next project that we worked on in this vein was for the, modestly, for the entire Mississippi Delta. We were asked to exhibit our New York project in the Venice Biennale, and I thought it would be interesting to combine that with a collaboration with Louisiana State University and a group there called the Coastal Sustainability Studio. So we partnered with them, and we went through the same process of analyzing, in this case, this huge region, looking at the topobathy, which we created that model of, and then focusing on the idea of divergence. This is something that scientist Robert Twilley at LSU had been advocating for a while, and that was to redesign the engineering, the plumbing, if you will, of the Mississippi, which currently flows 70% down the Mississippi, 30% down the Atchafalaya, reorganize that so more of that flow and sediment would get deposited in more places in the delta. And so here we identified 5 locations colored with the Olympic colors, squares, not circles. And and started to imagine and visualize how those diversions might work and what they might do. Now, it happens that Wax Lake, all the way there on the west end, exists already as a diversion, and so we were able to use that as the example of what could be done elsewhere. So again, this is water that comes down the Atchafalaya, particularly in flood conditions carrying quite a lot of sediment, and is diverted through the channel that you see there on the right out into the wetlands and helps to feed those wetlands. One of the reasons why the delta is sinking, as you read maybe over the weekend in the New York Times, is that it's starved of sediment, and that's because all the sediment is going out down the Mississippi out to the bird's foot and being dumped off the coastal continental shelf. Another one is Davis Pond, just south of New Orleans, which, and you can see here the scale of these diversions compared to the city. They could be quite substantial and make quite a contribution. One of the more provocative diagrams that I did was a series of flow diagrams based on Bob Twilley's idea of controlled flooding as opposed to flood control. The idea, again, of these diversions being a way of channeling the flood in a constructive and productive way. This was then in a case where 2.4 million cubic feet per second would be flowing down in a flood stage down the Mississippi. Part of it would go in the Atchafalaya and then get diverted according to this idea on the different channels. This is a lot like what was described in the New York Times on the weekend. This is now being implemented or slowly planned towards implementation. And of course, there's a lot of controversy and opposition, especially from the fishermen, for whom this would change the salinity in the water. So lots of complicated issues, but this was starting the conversation, supporting Bob Twilley's ideas, and exhibiting them, in this case, in Venice at the Biennale, with these two models that we produced, one of our project in New York, and one of the proposal for the Mississippi Delta. These models are an exaggerated topography and bathymetry of these two locations, exaggerated in the vertical dimension, so you really get a feel for the landscape. And then above that, rendition of the water as a volume floating above it, giving you a sense of the fit of the water into the landscape and of the water itself as a kind of object. This was produced here at Princeton. This is a plexi model of the water for the New York Harbor project, looking at it with layers to indicate the depth of the water, but also the green layers indicating sea level rise and tides. And then now it's the landscape of the same. You can see this is looking Manhattan on the bottom, so with the south more or less up at the top. And this was the equivalent model for Mississippi. So these were surrounded by more narrative material, but where they were also meant to be provocative so that folks coming into this exhibition would be intrigued and want to investigate further and understand, and also be thrilled by the beauty of this landscape, in this case, the delta and the diversions that we were proposing. We did a similar project fairly quick as part of a meeting that Princeton held in Shanghai over the summer before. This was based on a discussion with Howard Stone, where Howard brought up the question of what to do with the water after the storm. Once you accept that there is such a thing as controlled flooding, you have to figure out then how that water is allowed to go back into the ocean after a flood. And we hadn't really thought about that in great detail. So we took the opportunity of this project to think that through. Again, very large scale, somewhat intended to be provocative, but to raise some ideas and issues as well. We did, again, a topobathy of the landscape and the bathymetry to get an understanding of what we were dealing with. Did a lot of historical research, both of the flooding in the Pudong Peninsula that you see here on the right, and the hurricane tracks. This was again working with Ning Lin, who has also focused some of her research on Shanghai. And also, and here I want to read to you, also going back to the history of flood management in China. One of the emperors, named Yu the Great, controlled, I'm quoting here, controlled the devastating floodwaters of China through a moderate, soft infrastructural approach. Rather than building dams and high dikes to impede the flow of water, you created a system of irrigation canals that relieved floodwaters from the rivers into agricultural fields. He established low earthen dikes to guide the water's flow, allowed for the movement of water, and worked with the simple dynamics of gravity-fed hydrological systems to relieve pressure and reduce flooding. So these ideas are not new, but they do come in and out of focus, and it was fascinating to discover that in China, this general approach had been on the table now for almost 4,000 years. And Yu is a great figure in the history of China, partly because of his successes at managing the flooding of the Yangtze River. So going back, we looked at the edges, and this goes back to the project that we did in New York, where we were also trying to undercut the notion that there is this hard waterfront or water's edge that has to be maintained in a kind of frozen state. If you go back and you look at the coastline of New York, or you go back and you look at the coastline here of Pudong, it's obviously a very dynamic coastline and has changed over many years. And once you realize that, you begin to open up the possibility of change being constructive as well. So going back at all the different maps that we got our hands on, including some very useful ones that gave us the bathymetry information, we then started again to look at the atlas condition moving around the edge, understanding what, in this case, was carefully planned and executed coastal measures all along the edge of Pudong by the Chinese government, and mapping all of that to get an understanding again of what we were dealing with. And then, inspired by Howard Stone's suggestion, we started to think of a proposition of what you might call open polders. So creating a series of ridges in the landscape, which would also create a sense of place in this otherwise very flat landscape, could potentially create public parks and public space, but would also hold the water and allow it to drain more gradually in the event of floods. So we built this model, both some little test models and a large physical model that we took with us to Shanghai, inspired by the cheniers that actually already exist as the coastline has formed over time. These are ridges that accumulate from the hydrodynamics and turbulence that occurs along the coastline, and are accumulations of seashells and sand in a series of dune or ridges, which are called cheniers. So taking that idea, applying it as a design feature to create these open polders that would capture the water, hold it back, but allow it to drain through gravity back into the ocean. So now, coming to Hurricane Sandy, one of the things that happened after Sandy was that all these different projects that had been taking place in New York all came back very much to the fore and began to inform the conversations about what to do after Sandy to protect New York. One of the things that immediately happened, Michael mentioned this commission that Cuomo put together. There was a group, a subset of, there were many groups looking at all different aspects of infrastructure, electrical grid, and so on, but one of the groups that I was part of looked at land use, and we wrote a chapter in there which made use of the work that we had done and exhibited at MoMA as an example of what the future might look like. There was a lot of proposals and projects that were incorporated in this rather good document. It was overseen by Rockefeller Foundation. Judith Roden was the chair of the commission, and they produced a very detailed, very useful report, which Cuomo then promptly put on the bookshelf and forgot about. But it's there, and you can look at it online. It's quite a good example of what a blueprint for the future might look like. And then in New York City, the same thing happened, where the proposal for the development of the waterfront that was put together by the New York City Planning Commission, led by Amanda Burden, took many of our ideas again and images and used those as the examples of what the future would hold. More importantly, Amanda also took this notion of the topography, of the continuity of the landscape and bathymetry, and used it for the cover of the book, but also talked a lot about how, as she put it, the water could become the sixth borough of New York. And this idea that the water becomes a public space, analogous to what you see in Venice, for example, where it's a very vibrant public space in the city. That was something that really got incorporated in the conversation and discussions ever since in New York. Mayor Bloomberg also convened a group that put together a very detailed blueprint for what might happen in New York. One of the interesting things that happened in this process, both at the state and the city level, was the decision early on not to do a single project, not to do a giant gate that would close off the entire harbor and protect it in a sort of Dutch-style approach, which you could do connecting across the harbor between the barrier islands there, but instead to focus on a lot of small projects that would address individual community needs, and that was the basis of this initiative by the city. In parallel, the federal government that had appropriated about $60 billion for the recovery channeled some of that money through HUD, through a program that was initiated by Sean Donovan, who was then the secretary of HUD, who also happens to be an architect, trained at Harvard. Sean knew about the work that we had done at MoMA because he was part of a subsequent exhibit there on housing that Barry Bergdahl organized, and where Sean, who had worked in the city housing administration as well, contributed. And he used the model of that early MoMA exhibit to create a project called Rebuild by Design, which was funded by the Rockefeller Foundation, and appropriated about $800 million worth of federal money to a series of projects that were selected through a competitive process. One of those was what's been called the Big U, which is the softening and increased resilience of the edge going all the way around the bottom of New York, of Manhattan, from the east side around to Battery Park City. And that project was this kind of system of berms and parks along the same lines as all the studies that had been done before. The important thing here was the idea that these grants, which were block grants given by HUD, which, if you know something about these grants, are not constrained by the federal government to be applied in any particular way. They're just given to the states and city governments, and they can use them whichever way they want. The competition was intended to create a momentum and a degree of community commitment that would force the politicians to apply this money on the projects that had been designed and selected through this competitive process, and give the architects and landscape architects a leadership role in those projects. It hasn't always turned out quite like that. Part of the problem is that in the end, the projects have landed in the control of very large architecture and engineering firms who have subcontracted then the architects that initiated the projects, but it still has directed these projects to a more sophisticated and complex approach to coastal resilience. One of the best projects, again by Kate Orff, is the project for Staten Island, which is a system of what she calls living breakwaters along the edge that contribute to the ecology and resilience of the waterfront of Staten Island. And in this case, her project is led by the landscape architect Kate Orff, as opposed to one of the large engineering firms. And that makes a big difference, and that's been part of what this whole initiative coming from Sandy and the federal government has helped to reinforce. In parallel to that effort, we had a project here, also funded by Rockefeller, where we brought together 4 different universities to work in collaboration with the Army Corps of Engineers on something that we called structures of coastal resilience. Structures meant to carry the meaning of not just physical structures, but also structures as ways of thinking and framing the problem. And we were trying to do what we could to help adjust the approach that the Army Corps takes to coastal resilience. So we identified 4 different sites in the North Atlantic region and assigned each one to a different university. either architecture or landscape architecture program. And we also, again, working with Ning and Ning Lin and her group, in parallel started to develop some storm surge estimates for these 4 different locations as a way of testing the design approaches that each of them would pick up. So we had Rhode Island, New York, New Jersey, and Virginia as our examples. And we applied the topography model that I described earlier, built in each case a complete topography of that location, and then used that to start to do the analysis to predict what would happen in those locations due to the effect of sea level rise and potentially the changing hurricane regime over time. Michael Oppenheimer and his team put together the probability distributions for the sea level rise. So these were all specific to the 4 locations that we had identified. They're different because of different factors affecting each of the locations. And then Ning, working with Kerry Emanuel at MIT, used their approach to the application of the global circulation models as a way of generating synthetic hurricanes to get a much broader probability distribution of effects of hurricanes and then applying those to our storm surge calculations. So we were also creating a model of what would be, in our opinion, a state-of-the-art approach to evaluating coastal flood hazards and then applying those to the designs that we developed. So for example, in Atlantic City, Paul Lewis and his team here at Princeton looked at the community of Chelsea Heights in its current condition, which is was flooded pretty extensively during Hurricane Sandy, and then started to develop a strategy using the tools and ideas that we had been working on that was layered. So one aspect would be to try to intervene in the water to attenuate the energy of the storm surge and the waves, to provide some protection on the edge to keep the water out, but also to anticipate that in some cases the water would get in, and this is important, that there's no such thing as perfect protection, so that in those cases, when the water came in, the damage would be limited by the planning that took place on land. So these 3 parts always working together to improve the coastal resilience. So you see here his approach to that design, elevating the road along the edge, also actually elevating the roads within the community to create a system of polders to contain the water if it did get in, introducing canals to drain the water back out or also irrigate new wetlands that might emerge, and softening the edge with wetlands on the outboard side and also even on the inboard side of that edge protection. So then when the water came in, it would be contained to these polder-like parcels along the way. Part of that project, and there's more to it, and there's a website where you can look up a lot of this stuff. Part of that project was also to help visualize what adaptation would look like and help start a conversation with the community that would help them make choices about what they would like and prefer. In Jamaica Bay, we did a similar exercise. This was Catherine Sievet's project at City College in New York, and she came up with a combination of different interventions, including what she came up with, this idea of atoll terraces. What you see here in red was a way of capturing sediment in the wetland areas and island areas by building ridges that would then hold back the sediment flowing into the bay, or potentially you could put a sand pile in and allow it to circulate in the bay and get accumulated in those atolls. This is actually the one project of all the projects that we have that was adopted by the Army Corps, the atoll notion. And then also looking at ways of bringing water in through overwashes and the sediment in small storms so that you would improve the sediment supply of the inner bay, and then providing local protection in the different communities as well. So we then applied those ideas to our models and then developed this strategy which we call dynamic performance-based design, which is a way of visualizing the performance of these interventions through a series of probability levels, not just the 100-year flood, but floods with other, what did I do? That's it. Did I do that? No. So the matrix that you see here is horizontally a series of probabilities. So at the top is basically seasonal flooding, or what's sometimes called nuisance flooding. The next level down is the 100-year flood level. The next level is the 500-year flood level. Those are both levels that are mapped currently by the federal government. And then the bottom layer is a 2,500-year flood level, which is what's used for earthquakes and tsunami protection out west. And we introduced that as a way of representing the extreme event that we thought should be considered. And then the vertical lines here, I'll show you. So this is with and without interventions. And this would show you at a particular slice in time what the different probability levels it would do to you, or at a particular probability level, how things will change with sea level rise, etc. So the point of this was to help capture the range of performances and help incorporate our understanding of what the storms will do to us, looking at a range of probabilities and looking into the future as one way of planning both the implementation. Let's say you have a project that has to go through a series of stages of implementation. You could then evaluate the performance of that project within this framework. We also looked at the difference between the results that we were getting in terms of coastal flood hazards between our own calculations, NING's calculations, and what FEMA had produced, and I'll come back to that a little bit later, and seeing how in the event of particular storms or in different analyses you get different outcomes, and how important it is to come up with a process that captures that difference and makes the community safe regardless of what the outcome is going to be. As I mentioned, we produced a website with a lot of information on this project, and we're in the process right now of finalizing a book that will come out in a couple of months. The next project, and there are just two more here, is more recent. This was an initiative with the Regional Plan Association. Every generation they produce a regional plan. They just completed the 4th regional plan. And that's the blueprint for the region including Connecticut, New York, and New Jersey. I went to them and suggested that we work with them to give the plan a series of design studies that would help visualize what the future would look like, and focus in doing that on what we identified as corridors. So looking at corridors, the coastline, for example, as a corridor, the highlands, the whole range of mountains that crosses through New Jersey, New York, and Connecticut, looking at these corridors as a series of similar conditions that could be studied in tandem. So what kinds of solutions on the coastline can be applied in all these different places, and what can we learn from each of these solutions? That was the notion of the corridors. So we had the highlands as one, the inner ring of suburbs, which was one of great interest to the Regional Plan Association. The Triborough, which I'll show you in a second, is a rail line that exists through Queens and Bronx. It could be used as a kind of high line necklace of development and transportation. And then the coastline, the Bight, as it were, as another corridor. The work was, again, same model. The work was executed by 4 teams that were selected competitively, a jury chaired by Sean Donovan, and also funded by the Rockefeller Foundation. And then we had an exhibit out in the Rockaways in Fort Tilden Park and at MoMA PS1 of these ideas. And we're also working on a book of this work as well. This is the Triborough. This is the rail line. It's a little hard to read there, but it connects. Basically, it's the traffic for goods that go from Hunts Point down to the water in southwest Brooklyn, and then crosses the water on barges to New Jersey. Currently, it's just used for freight, but it could potentially be used as a way of connecting across the fingers of all the subway systems. So right now, the subways radiate from Manhattan. This would be a way to cross between them and allow Brooklyn and Queens to be interconnected in a much more direct way. And so this was a project around that idea, visualizing what it might become. Finally, the current project that we're working on together with Reza and Ming Lin is a proposal to protect the eastern part of Jamaica Bay, that's Kennedy Airport up there, with this yellow line. This is in progress, but it has the same ambition as the other projects of marrying the flood hazard assessment, storm surge calculations, and the protection measures that we are proposing, and doing it again in a series of layers. The purple line that you see back there is a proposal to elevate the road that goes along there and differentiate between a part of the community that would either have to elevate their houses to get out of the way of increasing nuisance flooding, seasonal flooding, and provide a certain amount of protection on the other side of that line, but also maybe over time recapture some of that land as floodplain and wetland. The yellow line would help protect JFK Airport, but also have a series of gates that would allow the water to flow back and forth. So there's a back layer that would be activated more frequently with seasonal nuisance flooding, and then a front layer that would help protect both JFK and the communities. It connects, it's about 20 feet high, and it connects back to the landscape at 20 feet elevation at both ends. So it's a complete dam, if you will, with a series of gates in between. Part of the idea here is that we convince the Port Authority that this is a really good idea for them. Notice there's a gate there for the runway. So it goes down every time a plane comes out. Not quite, but we convince them this is a good idea to protect themselves. They haven't really gotten it together yet to plan on how to protect JFK Airport, but in the process, get them to leverage that plan to help protect the communities and start thinking about increasing the size of the floodplains behind them in the community of Idlewild, which is subject not just to storm surge, but also to flooding from the streams that come down in there in increasing rainstorms. Again, you see the islands and the atoll terrace idea contributing as well. So we're in the middle of this right now, doing the studies, looking at different conditions along those edges and how we deal with them, and then working out the scenarios. In normal conditions, the water's out there and we don't have a problem. In some cases with small storms or seasonal king tides, the water comes in and is stopped at the purple line, and then this is what you see, the road elevated, and on the outside the elevated houses and increasing wetland recapture. And then when there's a big storm, it's stopped by the gates and the yellow line, and then when there's a really big storm, it overtops. So one of the important aspects of this thinking and planning is to accept that we don't always predict things completely, and there will be times when the water goes over the top of these structures. This is something, for example, that has not been considered for New Orleans, even though there was about $12 billion spent on its protection. What happens when the water is above the level that you've designed for? And one of the things you have to do is accept the fact that the water may come over the back and design the back for that water to flow, and also figure out how much water will get in. It's like a weir. So if the water's coming over, it's coming over for a limited amount of time. How do you calculate with some precision how much water that is? If you think about, for example, Hurricane Sandy, the water came in with the high tide. The high tide only lasted a certain amount of time. So how much water would have gone over a barrier that was high enough to contain that, and how do you plan for that on the backside? So it creates a problem, an interesting problem for thinking science, research, and design. So those are the projects, and hopefully that's helped sketch out the way in which I think the design has contributed to the conversation over the last decade and helped to move that conversation and also the evolving research that we have been doing. So lastly, maybe I want to talk just briefly about this initiative that we have tried to push, leveraging the work that we did so far, and that was to come up with a nationwide approach to coastal flood hazard mapping. Currently, the flood hazard maps that are developed for both river flooding and coastal flooding are done through the FEMA National Insurance Program, which are mainly meant to apply to whether or not you purchase flood insurance in any particular location. So the purpose of the map is to identify whether you should purchase insurance, whether you can purchase insurance through the federal program, and whether you should purchase insurance because you're located within the floodplain. That floodplain is defined by the 100-year flood line. They also identify the 500-year flood line, which you can also use, and localities can use those maps in whatever way they choose, but fundamentally it's all about the purchase of insurance. Because there's no other source of that information, it has also been used over the years as the basis for building codes and planning and other purposes, and it hasn't always worked so well. Now, one of the interesting questions about this is the way that it is produced. Historically, it was set up through FEMA, which is not a science-based organization, agency, I mean. It was established through FEMA, and FEMA, because it doesn't have the capabilities in-house to produce these maps, has farmed them out to private contractors. The result is that there is a big business out there in producing these maps, and there's maybe half a dozen or maybe fewer companies, 4 to 6 companies, that produce them nationwide. They produce them according to each their own distinct approach. They have their own computer models, they have their own information about the topography, etc. They model the hurricanes in their way. It's constrained somewhat by rules that are promulgated by FEMA, but fundamentally it still comes down to different tools and different algorithms that they're all using. And the result is that they're not all necessarily in sync where they come together, and there's a certain degree of variation that opens the door to appeals. So if you don't like what the map says about your community or your particular facility, you can go back to another one of these companies, and that company will give you a slightly different result. I have a friend who went through this process for Goldman Sachs and got very frustrated because he realized after a while that he could basically ask for a particular outcome, and the company that he was dealing with would give him that outcome. So it wasn't very convincing. The way in which we do earthquake hazard assessment is quite different. And so, and this is an example, for example, this is the flooding that occurred in red during Sandy and the 100-year flood plain. Clearly, Sandy was a hurricane that was greater than the anticipated 100-year storm, but it also showed that the distribution of that flooding was quite different than what had been anticipated. Ning Lin did a study here along the coast of New Jersey and found that the predicted areas of flooding due to the maps produced by FEMA was quite different than the flooding that occurred in Sandy. Not more severe, but distinctly different in distribution and layout as well. So it's pretty clear. Here's some examples that we did in our project looking at the different flood extent using the same return period but different approaches. So there's a lot of variation in the outcomes. This was also the case for earthquakes. And one of the ways in which this was addressed for earthquakes in the 80s and 90s was through a program that got initiated in the 70s under Nixon called the National Earthquake Hazard Reduction Program. And this was set up with a constant stream of funding. It gets reauthorized every 5 years. And the allocation of particular tasks to different agencies, from U.S. Geological Survey to FEMA to the National Science Foundation. The result of that also has been that through a program, and here's some quotes from that. So it is meant to do all the right things, make new and existing structures earthquake resistant. You could substitute flood resistance from earthquake resistance in all of this language, and you would see quite similarity of conditions and applicability. What came out of this, and I was part of this in that period of time, what came out of this was a consensus throughout the entire scientific community throughout the United States about the extent of earthquake hazards and the way in which to characterize them for design. The maps that were produced through a government-sponsored volunteer process, and they're still in use. They're continuously updated. They cost about $2 million a year to maintain. That's against $2 billion at least for the flood hazard mapping program. And they are accepted throughout the community. There's no fundamental difference between the results that you would get, and that's because through this process a consensus was formed as to how to organize the different types of approaches and the different algorithms that were being used. You can go to a website now and get the estimate of the earthquake hazard for your location based on longitude and latitude and or zip code. And if you go to somebody and say, gee, I got this really special facility, I need you to give me a more sophisticated outcome, they'll tell you, really, there's no point in doing that, just go to the website, that's the best information you're going to get. So to me, this is a goal of how we could approach the flood hazard mapping, and I think take the same probabilistic approach that I've outlined earlier, and that has been used also for NEHRB. We have a basis for this in the maps that have been produced by NOAA, at least for the Gulf Coast and the East Coast. So there are the tools there. NOAA has the capability of helping with this. USGS has a capability. It would be a complete change in how we approach things, but it would be an opportunity to develop a basis that everyone could agree on as the sort of lower bound estimate of what the flooding is likely to be in all these locations with different levels of probability, and looking into the future using some of the tools that I showed earlier. On the West Coast, there is a similar effort underway, which is following more the earthquake model to try to deal with tsunami hazard prediction and figuring out how to map in localities along the Northwest in particular, how to map the flooding that will occur in the event of a tsunami. One of the things that I've tried to do is to bring the community that is working on the tsunami problem together with the coastal flood hazards for the Gulf and East Coast and have them work together. But it's been very difficult, and I haven't gotten a whole lot of support in Washington for this initiative, but at some point, I'm sure we'll have a breakthrough. I think the community would be very interested in having this happen. I think the large companies that profit from the FEMA setup would probably not be so interested in having this happen. Okay, so in closing, I just wanted to bring up something else which I think is an interesting and important consideration, and that is the challenges in this work in negotiating the different approaches of different disciplines. I am a structural engineer. I practice. I teach in the School of Architecture. I don't teach in the School of Engineering. I would never have gotten tenure in the School of Engineering. So I snuck in through the side door of architecture. And the work that we've been doing here has been to try to frame these questions and display these ideas in compelling ways, work collaboratively with Michael and Ning Lin on these different projects, and set up a framework that could be used, for example, with this initiative I was describing on the probabilistic coastal flood hazard maps, using the design ideas, the contribution of the wetlands, the contributions of islands, oyster reefs, figuring out how to map those, figuring out how to incorporate those in those maps, figuring out what to map. For example, with the earthquakes, one of the key breakthroughs was the idea of mapping the response spectrum that shows the distribution of ground motion over different frequencies as they affect buildings. That was a big breakthrough in the 90s that led to the format of all the maps that was produced afterwards. There are similar basic ideas, I think, that would help to reframe the coastal flood hazard mapping process. And I think those can come through those collaborations. What's difficult is finding ways in which this research can be supported. I've had a good run with the Rockefeller Foundation, but they have a new president, and the new president decided that resilience is no longer of interest. So thus ended our good run. There are lots of little pockets of support out there, but it's not it's not, for example, an NSF priority or other agency. So it's tricky how to get the support for this. It's also tricky how to set this work up in such a way that it is appropriate for someone looking to get a PhD and to go on and get a teaching job and tenure at another university. How can this work be organized in such a way that it will fit the needs of that kind of career prospect? So part of the challenge here has been dealing with the topics. Part of the challenge has been to help frame these concepts. I think we've had a lot of success influencing New York and the federal agencies, or in some cases. But a big part of the challenge is how to make this kind of work continue and thrive in an academic environment. So I'll leave you with that. Thank you very much.
You take a few questions?
Yeah, of course. Yep.
Yeah, under the Obama administration issued an executive order changing the flood risk management standard, and then Trump rescinded that this summer. What are the implications of that?
So that was a very great effort by Alice Hill and others that tried to make do with a very compromised situation. So what they proposed was that there were these three categories of, one, take the existing flood hazard maps and add a certain amount of freeboard and design for the 500-year return period. And that would be appropriate for federal facilities. The problem with that is the maps are generally wrong, and so basing that on those maps was a compromise that they had to make because they couldn't change the maps, and Alice Hill and everybody involved understood that. There was an opening to go about it your own way and prove independently that your approach was appropriate. The difficulty with that is that there's no consensus in the community that you could turn to and say, we're meeting the minimum standard in the way that we're doing that. You could always find somebody else to come along and contest that. So like many of the things in the Obama administration in this domain, it was a compromise, and it never really went to the root cause and problems that we have.
So the rescinding,
rescinding is a bad thing, but the thing itself was pretty much of a compromise, in my opinion.
Dan? How do you come to consensus? I mean, you have many different designs, some soft, some hard, some retaining water, some moving mud. How do you test the known alternatives to come up with one design that tries to satisfy a lot of competing demands?
So the way that worked in the earthquake community, but it's the same, I think it's the same thing, is that there are maybe 100 people who are focused on this problem in the United States, plus or minus. And they all recognize that there's a big problem here and it's not working. What we did in the earthquake community is we brought those 100 people together, and they worked in an organized fashion supported by the federal government through the NEHRP program. And over the course of the years, revamped the whole system using a decision tree model and other tools to compile the expert opinion when there weren't full answers. The basic idea is out there. Even the Army Corps agrees nature-based features are important. We have to use wetlands to help dissipate. They provide ecological services. All the ingredients of this are out there, lots of people working on it, but no organized way that it's all coming together. And I think whenever I talk to this community, it's quite clear that you could arrive at a consensus given the support and the likelihood, and this was the problem with the Obama administration, is that there was never the fundamental support for this initiative to happen, with a sense that after spending 5 years on it, you would see an outcome. I think the problem was NEHRP was set up as a congressional program, and it was passed as a law in the 70s. The likelihood that anything like that would get passed through Congress in the last 15 years was, slim. So that's why that path wasn't
So
available.
so at the current, we have options that appear on maps, but we haven't had any set of trade-offs to pick a solution.
The National Research Council, the national academies, they want to do this. They would love to do this project, but they don't have the funding for it, and they cost a lot of money. And so they have to get, Army Corps or somebody to say, okay, here's $5 million, go ahead and do it. And that hasn't happened.
The coastal problem is a lot more complicated. I think at every community, the answer is, the compromise is different. What's appropriate just from an abstract point of view, but the political complexity is just immense.
Yeah. Right, but that's no reason not to map correctly. I mean, currently it's a mess in part because nobody believes the basis of the conversation.
We're at 1 o'clock. Guy, do you have a few minutes to hang on?
Of course.
I'm sure a lot of people will like to chat further. So let's thank Guy.
Thank you.